Alright, so part A of this one asks me to find dy dx. I'm just going to use y prime notation because it's a little bit more compact. So I am going to derive with respect to x. The first term here is just power rule, so I get negative 12x. Then the second term, I've got this piece and this piece, and I'm going to do product rule on it. Maybe I'll actually underline the whole plus so that we see that the plus goes with both pieces. So the derivative of the blue is plus 3 times the y is y, that's the second. And then I do this plus the derivative of the second, so that's plus y prime times the first. Well, the first is 3x. And then I do plus 2, well, for this guy, I need to do power rule, so the 3 is going to bump down to a 2 and get multiplied by that. But then I need to do my chain rule, which would be multiplying by the inside, or the derivative of the inside. So I get 6y squared, and then the derivative of the inside is times y prime, and it's equal to 0. So from here, I'm going to group things. So I will write y prime, open a set of parentheses, and then write my equals. So this guy does not have a y prime. You should notice that. This guy does not have a y prime. So those guys are going to move over to the other side. When they move over to the other side, I get a positive 12x. And then I get a minus 3y because they both change signs. And at that point, I'm going to cross these guys off because they're no longer there. So now what I need to do is rewrite this right here. Notice I've got a y prime out here. So I always like to think of it as what would I need in here to be able to get back what I have up there. Well, for this term, I would need a 3x, and then plus, and for this term, I would need that 6y squared. So I'm going to get 6y squared. From here, I'm going to divide everything by 3, or sorry, divide everything, you may see why I said that, divide everything by that, set of parentheses over that, like that, which gives me y prime equals 12x minus 3y over 3x plus 6y squared. Now, depending on the type of problem, that might be sufficient, but I'm going to simplify this a little bit. I actually could have done this up here. If you look at this line, 12 is divisible by 3, as is 3 and the 6. So at this line up here, if I wanted to, I could have divided everything by 3 and then done this same structure and get the answer that I'm about to get. Instead, I'm going to factor them out here. Notice this has a factor of 3, and so does that, and this, and this guy does, and that guy does. So what I'm going to do is write equals 3 open close over 3 open close, and then fill in what I need. Well, I would need a 4x and then minus y. And down on the bottom, I would need a x plus 2y squared. Then these guys are going to cancel and give me that my final answer is 4x minus y over x plus 2y squared. And I'm done. Alright, so for part B, it asks me to find a tangent line to this thing at 1, 2, and I just want to point out one issue. If I plug in x equals 1 and y equals 2 to this equation, it doesn't actually give me that. So it's a little bit of an invalid question, but I'm going to leave the video as is just because it demonstrates how to find the equation of a tangent line. You can watch, if I put negative 6 times 1 squared plus 3 times 1 times 2 plus, fix it, 3 times 1 times 2 plus 2 times y is 2 cubed. That comes out to 6 negative minus 6, or sorry, plus 6, and then plus 16, and that's definitely not equal to 1, which is what that curve says it is. What does that mean? It means that this point is not on that curve here, but I'm going to go ahead with the video anyway, just as an explanation for how to find a tangent line. So this next part of the question asks me to find the equation of the tangent line to the curve at 1, 2, and I've already found dy dx in part A. So anytime I see tangent line, I always write y minus y1 equals m times x minus x1. It's point slope form, and I just have to figure out the different pieces that I need to plug into all this mess. So notice 1 is my x value and 2 is my y value. So those are actually the x1, the 1, and then the 2 is my y1. In other problems that you've done with tangent lines before, it may have been like more work to get all those different parts, but this is just x1 and this is just y1. So I've got y minus 2 equals, I'm going to leave it blank space for the m, and I'm going to write x minus 1. So from there, I just need to evaluate dy dx, what I got in part A, and it will give me the slope. So I'm going to evaluate it at those points right there. So I'm going to write dy dx. Hopefully you've seen this notation with the big bar and a 1, 2. That means evaluated at. So I get, remember this is x, this is y. I get 4 times 1 minus 2 all over x is 1, so 1 plus 2 times 2 squared. So the top should simplify to 2, and the bottom gives me, this is 8 plus 1, so I get 2 over 9. So that goes in for my m. I write 2 over 9. And that is my answer.